Now, let me draw some tangents here. So, in your mind, look up please. Brandon, Louise, look up. In your mind, draw a tangent on that graph when x is -4. Is the slope of this tangent positive or negative or what? If you can imagine a tangent when x is -4. Let me zoom down a bit. So what do you think?
Negative.
Negative slope? Big or small? No, I think big. Because it's quite steep. So what I'll do is I'll draw it in. No good. Wait. -4. Oh, hang on. Start over. Right. -4. Right, let's try this again. Draw, and then this one here. Draw. There we go, -4. Now, imagine I draw an tangent at... What's wrong, Hugh? You're enjoying this? Good. I draw a tangent at -2. Positive or negative?
Negative.
Negative. Bigger or smaller slope than the one I just drew?
Smaller.
Yeah, smaller slope. So, tangent again at -2. See, there it is there. And then let me do in a tangent at -1. See, there it is in there. Okay. Now, what about if I draw a tangent at 1? Yes. So, let me just zoom in a little bit first. Oops, one too far. So there's my three tangents, blue, black and green, and the tangents are moving along here. What about the tangent here at 1? Horizontal line, yeah. If I draw that, 1. See, the horizontal line here at 1. What's special about this point here at 1 though, on the graph? What's special about this point here? Not midpoint, minimum point. So you notice that you get these horizontal lines when you try to draw tangents at places which are at a top of a hill or when they're at the bottom of a hill. You notice that the slopes here, the slopes of the tangents are 0. So this is our first result for this lesson, is that now these points here, what are they called? I think we had this vocabulary in semester 1. What are these points here called? No. Give me the other word I gave you. Yeah, you can call these points turn-in points. That's one. But there was another word I gave you. What one? No, not this one. Vertex. Well, vertex for 1. Vertices for 2. And also, this is a new one which I haven't told you yet. You can also call these points stationary points. So at turn-in points, the slope of the tangent will be 0. Okay. So that's the important result now. Do you have that? Can I scroll down? Yep. Oh, are we just waiting for Ali or someone else?
Someone else.
Alright then, needs to be at least 2. Okay. Now, do you remember earlier in semester 1, if I gave you something like this, y equals x squared minus 2x plus 5, do you remember how to find this turning point here? What do we need to do? Yeah, I heard mumbles of the right answer. What is it? No? Good. Was it you that mumbled the right answer? Thank you, Lou. Complete the square. You remember this? So if I complete the square here, I get x minus 1 squared plus 4. So what's this turning point here? What's the x and the y? 1 and 4. But there is another way to find it. Because what should the slope of the tangent be at this place? Should be 0. And what is the slope of the tangent for this quadratic? What is the result here? We did this in the last lesson. What's the slope of the tangent? Yeah, 2x minus 2. And what do you want this to equal? You want this to equal 0. Which means you want 2x minus 2 to equal 0. So 2x equals 2. So what does x equal? 1. Hey, look at that. Same answer. But the problem with this is we don't have the y if we do it this way. So how can I get the y? Yeah, just substitute it back in here. And you get y equals 1 minus 2 plus 5, so that's 4. So therefore, y equals 4. So look, it's the same answer. Now this method might seem longer, but it has one big advantage over the other method. What might that be? What is the big advantage of this new method? Any ideas? No ideas? No? Alright. In the
slope.
Yes, you're right. You could find the slope of the tangent as well if you needed to. But I was thinking of something else. In the first method, completing the square, what type of problems could I use this for? I can only do it for what type? Quadratic. However, in my second method, I could do it for any function. It doesn't have to be quadratic. So let's look at an example with a cubic. First, let me make a cubic. Oh, what, do you need to write this down? Yep. Yep. Okay. So let me just make up a cubic first. So let's do. Hang on. All right. So here's my cubic. X cubed minus 6x squared plus 11x minus 6. So that's y equals x. Oh, I forgot it already. X cubed, yeah, x cubed minus 6x squared plus 11x minus 6. Is that it? Yeah, that's the one. In fact, we know what the cubic graph looks like. It goes like this, doesn't it? How many turning points are there here? There's two. There's one here and there's one here. What's special about these turning points, like in the last example, is that the slope of the tangent should be 0. So the slope of the tangent here is 3x squared minus 12x plus 11. That should equal 0. Now this has factors. We'll need a 3x, I think, and I don't want to put the 11 here, so I think I should, oh dear, does it have factors? Alright, let's just use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac 121 all over 6, 12 plus or minus 21, 31, 41, 22. It's going to be decimals, isn't it?
No, that's not true.
What's wrong?
77.
What's 77?
That's 7.7.
Look, guy without a calculator, room full of students with calculators. Tell me what the numbers are.
132.
Sorry, what should be 132?
121.
Should be 132. Okay, so then that changes that into 12, is it? Thank you. Okay. Now this has two answers. We can do 12 minus root 12 divided by 6. That unfortunately is going to be a decimal. 4? Oh no, I think it'll be an ugly number. So 12 minus root 12 all over 6, what's that please? Yusra, you got it?
1.42.
1.42, okay. Or, now if we do 12, sorry, what was that, minus or plus? We did minus, okay, 12 plus root 12 all over 6.
2.577.
2.577, okay. Now look, I won't bother to do it because you know how to do it. How do I get the y values here? What do I do? Yeah, I just take these two answers here and substitute them back in here, and I get, oh okay, go ahead and do it. I don't want to disappoint you. So give me the two y values, please. You have the first one, user?
Second one.
Yeah, the second one, okay. What is it?
5.
Say again?
21.5.
21.5, okay. Is that the first one?
Yes.
What is the 6.11?
1.
Okay. So if you look at it like this, you need me. What's wrong? Go through there? Oh no, you go down. Sorry. Oh, you'll find your way around. Don't worry. Which one is it? What is it?
0.38.
For the first one?
Yeah.
0.38. Okay. Yeah? So look, we have our two turning points now. If I go back up here, here it is. This one, Yusra, are you sure about this one?
minus 0.3.
That sounds better. What is it?
Minus 0.38.
Thank you. So this first point here up the top is 0.38 and 1.42. And the second point here is minus sorry, I wrote that backwards. 1.42 and 0.38, and then this one here is 2.577 and minus 0.38. So there are 2 points. Now let's look at the graph for this so we can see that nice and clear. If I draw the graph here, so, no. Okay, so the first one, look, there's 2, there's 1, so the first answer looks like, I don't know, around about 1.5, something like this. What answer did we get? 1.4. It's not bad. Now, whoops, what's the y value? It looks like it's about nearly 0.4. Is that what we got? Yeah. Now, yeah, the second turning point, what do you think the x value is? Well, here's 2 and here's 3, so it's about 2.5. And what is it actually? 2.57. And the y value is around about minus 0.4. It's the same. So what I'm saying is this method is very, very important method. It's a very good method for finding the turning points here and here. Okay. Let's have a look at one that's a little bit more difficult now. So just write that down. Make sure you have this. And let's see. We have here cubic. Yeah. So I want to do one with a log. So I'll do one for 3 here. So you read this to me in one moment, please. In a moment, yes. Is that English?
Yes.
Okay. Okay, you have this? English, yeah. Okay. So, I imagine that you can probably see some pattern here. So if you have a quadratic, how many turning points do you have? 1. Or 1. And if you have a cubic, how many turning points will you have? You'll have 2. And then if you have an x4 equation, yeah, you could have up to 3 turning points. Okay. Let's have a look at one with a log in it though. So I'm actually going to do number 3 in your book there. So Yusra, what is it? Y equals?
Log x 18.
Yep.
Minus x squared minus 16x minus 2.
Minus 2. So we want to find the turning points here. So before I find them, I'll make the graph so we can estimate roughly what it should be. So we have log x power 18 minus x squared minus 16x minus 2. Right. Oops. Zoom out. Weird graph, isn't it?
Yeah.
The log is making it weird. If it was just a quadratic, what shape would it be? It would just be like a hill shape, wouldn't it? Because you have, see here, a minus x squared, so it's a hill shape. But the log is actually making it a little bit weird. So if you look at this graph, how many turning points do you think there are? 2. What about this one here, though? 4. My goodness, how can you see 4? Where's the?
I mean for 1.
Yeah, where's the 4 points? So where's the first one? Do you see it?
Yeah.
What is that? I want to see the 4. So where's the first one? Where's the first one? Give me the x value for the first one.
Maybe
Minus
minus 17.
Yeah, somewhere around here, isn't it?
And 0 and minus 50.
Yeah, we think maybe this one.
Yeah.
And then what about the other one?
Minus 150. No, minus 0.
One?
One.
So here, isn't it?
Yeah.
That's a bit clearer, isn't it?
Yeah.
About here. Yeah. Whoops. Now, you think there's one here in the middle. So we think there's 3. Well, sorry, you think there's 3. So let's see what happens. So first, what do I need to do about this 18 though? Put it in the front. Okay, so what's the derivative here? It'd be 18 over x minus 2x minus 16 equals 0. Now we've seen how to deal with these problems. What should we do here? Multiply everything by x. So you get 18 minus 2x squared minus 16x equals 0. So we kind of have to pause here. What type of equation is this? Quadratic. How many solutions? But how many did you think there were?
3. They
3.
think
Yeah, they think there were 3. Yeah. So let's solve this. First I can divide everything by 2. So you get 9 minus x squared minus 8x equals 0. So you have x squared plus 8x minus 9 equals 0. Is that right? Yes. So let me see, what are the 2 roots here? 9 and a 1. Did I do that right?
Yes.
Yeah.
Close minus 9.
it was supposed to be negative x squared.
But I took everything to the right. So it's x squared plus 8x minus 9. So this would be x plus 9x minus 1. So then x equals 1 or minus 9. You know, which is good, because these are kind of the numbers we were saying a moment ago. In fact, we did actually say x equals 1, we thought was one of them. So I just need to switch back to the graph for a moment. But there's something we didn't do at the start, which I should have done at the start. I should have said what values of x we can use. So if you look at the equation, what values of x can I use? What is the domain? What is the allowed values of x? Nope. No, x has to be greater than 0.
Mine.
Any number.
Not this either. Not this. You know for log, here must be positive, right? But when you have something to power 18, it's always positive. But we also know we can't put 0 into log. So in fact, we just cannot use 0. But of course you can see that on this line as well, because you have the x here. You also have x is not 0. Now if I go back to my graph, I said, what was my first answer? Minus 9 and then 1. Let's look at the graph. So if you look here is minus 9. Is that a turning point? Yeah. Here is 1. Is that a turning point? Yeah. But it looks like we have a value for 0, even though we just said there's no value for 0. So what do you think the x is? Well, 0. And what do you think the y might be?
0.
Well, no. 0 will be here. Minus 50. Right, let's zoom in to see if we can get it more accurate. So where's center on, cross, and then zoom in. Oh, it's not quite minus 50. What is it?
Minus 70 maybe.
Maybe minus 70. All right, hang on. So let's zoom in a little bit more. Oh, right, no. What do we think it is now?
85.
All right, okay. Hang on. So let's zoom in a bit more. Oh, no, it's not. So what's happening here?
The base is 1.
Yeah, what you can't see on this graph, if I go back to the, if I zoom back out, what you can't see is actually this is shooting down to minus infinity, that it has no value on the y-axis here. It's shooting straight down to minus infinity. Okay, so I know it looks like it has it here, but if I now zoom in, oops, wrong way. See, I'm all the way down to minus 130. It's just going straight down to minus infinity. And you can't see that here. So, how many answers do we have? We have 2 turning points. Even though it looks like there was 3, it's actually only 2. Okay, so I wanted to do this example to show you how good this method is for finding the turning points. Okay. I think the other important thing about this lesson is vocabulary. There are many different words for turning point. So what are the different words we have for turning point? We have turning point, stationary point, vertex. There's actually more, which I didn't tell you, but I used them all in the workbook. Critical points, extreme points, maximum minimum points. Is that it? Or is there even more? That's all I could imagine. Inflection is actually something a little bit different, which we'll do next time. Anything else? Critical we have, yeah. I think that's all. In the exam, which is most important for you, they tend to use turning point and stationary point. Is the vocabulary they use in the exam. Sometimes they use max and min, but of course everybody knows what max and min is. Stationary and turning point. So you should at least highlight those words because they're the most common in the exam. Right. I want you to do one of each type. So there's a cubic, there's a log, there's a quadratic, Alright, so I want you to do one of each type, a quadratic, a cubic, a log. So anyway, the ones I picked out, you note these. Number 1, number 5, yeah, 11, 27, 28. And 28. That's one of each type. A quadratic. Yeah, 5 is a log, isn't it?
No, 5 questions.
Oh, 5 questions. Yeah, 5 questions. I gave you a quadratic, a cubic, a log, a sine, and an e. One of each type. So you start them now, please. For 10 minutes. But since you didn't get a break, we'll finish at 1:40. Yeah, I saw it hanging around the side. Probably get lost. Oh yeah, Tom Stephen has a message for you. Get lost. Okay. He'll appreciate that.